we'll need to make sure we go back and review that, but we're done with the lessons on graphing. Today we're going to focus on the values. It'll look very similar to questions that you saw in your gateway, but it's basically like you're undoing that. They're telling you the answer on the gateway, what angle would it have been? Okay, now it's not quite that straightforward because there are those restrictions we saw on our graph. Those restrictions happen when we're doing our values also. So, unicircle gateway. No, well, yes. I would. The reason that you only look at quadrants that are up there, that they are only defined in 2 quadrants, similar to the reason we talked about yesterday when we were looking at the graph, is that we have to restrict it so that it is a function. It is restricted to just 2 quadrants in which they are called the principal value. For example, one of the questions that you will see will be something like, what is the inverse sine of 1/2? Well, guys, there are infinitely many angles that would give us a sine value of 1/2, because every time we went around the circle and stopped at the same place, it would have a sine value of 1/2. So we do the first one. The first one in quadrant 1 and the first one in quadrant 4 for sine and tangent. Cosine plays by its own rules because of where it is positive. So what you will always see is what I draw off to the side is a visual representation of this information. Where are they defined? Sine and tangent are both defined in quadrants 1 and 4. Sine is positive in quadrant 1, negative in quadrant 4. The small difference between the two of them is tangent's not actually defined at pi/2 and negative pi/2. So as I draw that picture, you'll notice that on my tangent ones it has open dots. But again, representing that we only find angles or answers in those 2 quadrants for inverse sine and inverse tangent. But if I were to highlight those 2 quadrants for cosine, I would have to put a plus in both of those quadrants because cosine is positive in quadrants 1 and 4, which is why inverse cosine is not defined in 4, but in 1 and 2, because it's positive in 1 and we need somewhere that it is negative. It's negative in quadrant 2. Those little pictures that I have drawn off to the side, which you're going to notice as you check like my handwritten answer keys, as I do problems in class, I draw that little picture for myself on almost every problem. Very similarly to when I were doing a unit circle question, a gateway question, that when it asked me to do something like the sine of 7 pi/6, I would have started by drawing myself a picture of 7 pi/6, right? Kind of that same idea is just reminding myself what it is that we're looking at as far as where our answers can be. Okay. On this page, I'm basically going to highlight the only answers that you can have. You'll notice that inverse sine and inverse tangent are grouped together because they're from the same 2 quadrants. Inverse sine and inverse tangent go quadrant 1 to quadrant 4. All answers are positive in quadrant 1, and negative answers come from quadrant 4. And it's just the angles that would fall in those in terms of radians. So reminding you of what those angles are: pi/6, pi/4, pi/3. And the wonderful thing about inverse sine and inverse tangent is that we also use quadrant 4, which means I can just put a negative in front of each of those angles and it would drop us down into quadrant 4. So if my answer or my problem started out negative, I would use the negative version of each of those angles: negative pi/6, negative pi/4, and negative pi/3. They also hit this axis. Both of those will hit that axis, which is an angle of 0. The last 2 angles that you'll see, I'm going to highlight in a different color because they are specific to tangent only. Tangent hits at this line up here, pi/2, but inverse sine does not. So pi/2 is only an answer I can have for an inverse sine question. Same thing with negative pi/2. Inverse tangent is not defined at negative pi/2. So if I were to use that, it would be for an inverse sine problem only. If you remember yesterday, that would be where the asymptotes were drawn on our tangent curve, right? So it never actually got to those values, which is why those values are not included for our tangent curve. Cosine is quadrants 1 and 2. Quadrant 1 will look exactly like quadrant 1 does over here. we've got the angles pi over 6, pi over 4, pi over 3. Starting at an angle of 0, this axis would be pi over 2. But what changes is when cosine is negative, it's in quadrant 2, not quadrant 4. Well, we can't just put a negative in front of our angles and get to quadrant 2. So you have to think about what is the pi over 6 angle that would put us into quadrant 2. So remember that a half a circle would be 6 over 6. So if I back up 1, I would be at 5 pi over 6, right? So the answer that you can get for a cosine in quadrant 2 that had a reference angle of pi over 6 would be 5 pi over 6. It's the same for all of our angles in quadrant 2. There will be one less than the denominator. If I had a pi over 4 in quadrant 2, it would be 3 pi over 4. And a pi over 3 in quadrant 2 would be a 2 pi over 3. And if I got all the way to that axis, it would be an angle of pi. They are not. They would give us a negative answer. That's why we would pick them. Quadrant 2 of inverse cosine is by far the hardest thing in this entire section because we want our answer to be negative and it won't. Inverse cosine will never have a negative answer. Okay, inverse cosine will never, ever have a negative answer. And that's going to go against what we want to happen because inverse sine and inverse tangent do. They have lots of negative answers. It will match whatever the problem starts as. Cosine will not. Yes. Only sine can have an answer of pi over 2. Tangent is not defined there, so if we wanted to say that, which you'll talk about this a little bit more on Monday, if we wanted to say that for a tangent answer, you would have to end up saying undefined or does not exist because we don't have an answer at pi over 2 for tangent. All right, does anyone still need this page? Okay. Now, this page is a little bit more specific towards my hand trick people, although that you can get a little bit out of it if you are like a special right triangles person. The hard part about these is that you see the simplified version. So we spent all this time rationalizing our answers, like when we saw it on our hand trick especially, or on our special right triangles. Well, today you're handed the rationalized version, and you kind of have to think through what is the unrationalized. So let's just go through this real quick. If I'm a hand trick person, this is also a good reminder for our hand trick. Remember, it goes pi over 6, pi over 4, pi over 3, right? So if I'm doing tangent of pi over 6, I pull back my pi over 6 reference finger. I look at the back of my hand. Tangent goes square root of fingers over square root of fingers. So square root of 1 over square root of 3, which rationalized to square root of 3 over 3. Pi over 4, reference angle, on my hand would be a square root of 2 over square root of 2. That rationalizes or simplifies to 1. This is probably the number one missed problem because people want an answer of 1 to land on an axis. But in tangent, it's actually at a pi over 4 angle when it's equal to 1. Okay? Pi over 3 is here. That would be a square root of 3 over square root of 1, which simplifies to square root of 3. This is what you see in your problems today. So if you are a hand trick person, you kind of have to think backwards through the simplifying process. Or if that's hard for you to think backwards through, you kind of just have to sit there and think about the 3 options and which one would simplify to what's in the problem. Okay? If you are a special right triangles person, you had a couple options of how to do your special right triangles, right? You could do the original version that we started with, or you could do the version where the hypotenuse was 1 so that it was specific to the unit circle. Today, I would suggest that you go with the option where the hypotenuse is 1. So I would, if I was a special right triangles person, as I'm doing today's work, I would draw myself a model of each. One of the pi over 4, and I'm going to go with the radian measures here. Specific to the hypotenuse being 1 for the unit circle, remember that the pi over 4 special right triangle model, your sides would be square root of 2 over 2 and square root of 2 over 2. Your 30, 60, 90 model, or pi over 6 and pi over 3, again, specific to our unit circle, so the hypotenuse being 1 across from the pi over 6 would be 1/2, and across from the pi over 3 would be square root of 3 over 2. I would draw those on my problem. Okay, and it'll make more sense as we go here in just a second. But that's what you're kind of thinking through. So, what does a problem look like? A problem will look like this. Find the value for the inverse sine of square root of 2 over 2. Now, the questions off to the right-hand side, these eventually happen in my head. These are not problems, these are not questions that you would be answering alongside these, is that you see this problem, you give me an answer. The same way we started doing our unit circle. But they are things that I have to think through as I start these problems. So where is inverse sine defined? That's where you would see me draw this picture for inverse sine. Quadrants 1 and quadrants 4. This is a positive number, which means of these options, positive is quadrant 1. Our answer is going to fall into quadrant 1. I am a hand trick person, so I would go make my hand look like square root of 2 over 2. So a quick reminder on hand trick. Remember that it goes alphabetical order. Cosine numbers, comma, sine numbers, that they are always square root of fingers over 2. So this is the number of fingers I should have for a sine of square root of 2 over 2. I should have 2 sine fingers. That would have to be my reference angle if I have 2 sine fingers. What is that angle? Pi over 4. So our answer, pi over 4 in quadrant 1 is pi over 4. So another way, again, of thinking about these problems is what angle do I take the sine of to get this answer, right? Go back to your gateway. What angle do I take the sine of and get an answer of square root of 2 over 2? Pi over 4. Questions? Okay. I will kind of highlight the ones that always catch people. This is one of them. Cosine, inverse cosine of a negative. Again, remember, cosine is never a negative answer. So even though the problem starts out negative, we will never have a negative answer for an inverse cosine. So, where is it defined? Remember, cosine is the unique one, defined in 1 and 2. Because this is a negative, I know that my answer is going to fall into quadrant 2, because that is where cosine is negative. Again, if I am a hand trick person, I would now go to my hand trick and give myself 3 cosine fingers, starting at the thumb, right? 1, 2, 3, which means we have a reference angle of, what's this guy? Pi over 6. So a pi over 6, but I want the pi over 6 that's in quadrant 2. What's the pi over 6 in quadrant 2? 5 pi over 6. Remember, we just talked about like 2 pages ago, it's always going to be 1 less than your denominator. So 5 pi over 6 would be the pi over 6 in quadrant 2. That would give us a negative square root of 3 over 2 cosine value. Questions? So many people are going to want to say that it's negative pi over 6, but negative pi over 6 would still be a positive cosine value. That's why that doesn't work. I wish it did, but it doesn't. Okay. All right. This is the other one. I kind of highlighted it. I will highlight it one more time after this. But this is the other one that's really going to bother people because when we see the numbers 1, negative 1, and 0, we always want all of those to fall on an axis, but tangent does not. Tangent of 1 does not, yeah. So where is it defined? We've got the options of quadrant 1 and quadrant 4. This is a negative number, which means my answer is coming from quadrant 4. Again, sine and tangent are nice ones because whatever the problem starts out as, that's what the answer is. If it starts as a positive, my answer is positive. If it starts as a negative, my answer is negative. This means my answer is going to be negative. This is where we go back to that chart, or you just go through your options. Which one of these simplifies to 1, right? If I'm a hand trick person, I can kind of just think through that. This would be a square root of 2 over square root of 2, pi over 4 reference angle. puts us into quadrant 4 would be negative pi over 4. Questions? Right, right. Other questions? I have a couple for you to try on your own before we start talking. We have not talked axis angles yet, but let's finish up. Try these 3 on your own. I will come around and help if you have questions. What do I do with what? Are you a special right triangles person? Are you a memorized quadrant 1 person? So I would draw myself a quadrant 1. Yep, so these, so if you're a memorizer of quadrant 1, these become my answers, right? For quadrant 1. The questions then are in these parentheses. So like this one right here would be what? Our square root of 3 over 2 comma 1/2. So if it's a cosine question, we'd be looking at the first number. What is the inverse sign of 1/2? I just find where it has a sign value of 1/2. That's my answer. Negative pi over 6. Then memorize quadrant 1. You can do that. Yeah, that's fine. So if I'm a memorized quadrant 1 type of person, you got to know that each of these ordered pairs goes cosine comma sine. So if I'm trying to find the inverse cosine of square root of 2 over 2, I go over there and I find where the first value, because the first one is cosine, which one of those angles is the square root of 2 over 2 for the first value. That's my answer, pi over 4. But then you have to pay attention to which quadrant it falls into, right? The things you do not see in this method is tangent. Okay, so that's where you have to be. It's like slow down a little bit and think tangent, remember, is going to be sine over cosine. And it actually ends up being the numerator. 1 over square root of 3, square root of 2 over square root of 2, square root of 3 over 1. If you want to look at them that way. Then it ends up being the numerators because the denominators will all cancel. So it goes sine over cosine. So it would be 1 over square root of 3 is unsimplified. Okay, square root of 2 over square root of 2, and square root of 3 over 1, which is square root of 3.
Wait, so what about the quantity? So how would you know if it's negative or positive? Is that the only thing?
The problem itself tells you whether it's going to be positive or negative. And cosine you have to pay attention to. You would have to translate that into quadrant 2. It would be this angle in 3 pi over 4 to put you into quadrant 2.
So the only difference for cosine you need to put in quadrant 2?
Correct.
Okay.
For a negative.
For a negative.
Yeah. If it's positive, all answers are in quadrant 1. Doesn't matter what problem you're doing. Yeah.
I don't know, that's just a lot easier than both of them.
Then use it. That's why I give you multiple methods. Use the one that works for you.
1, 2, 3, 3, 2, 1.
using this, it'd be your numerators. So 1 over square root of 3, square root of 2 over square root of 2, or square root of 3 over 1 are all unsimplified, but that's where you would start the process. Square root of 3 over 3. That comes from 1 over square root of 3 rationalized. I'll add that. Feedback taken. You can't. Oh, I know. Sorry. I need like multiple smart boards here, so Cole can see the lesson after he's done sleeping through it. Okay. Okay. Now that we've got all that figured out, yes, we have multiple options. Tanner. I do not. No, I don't. Okay. Let's get through these. We do have a little bit more to talk about because we have not talked on an axis, right? So we do have just a little bit more to cover here. Use whatever method. Obviously, clearly, we're liking some other methods here. Use the method that makes the most sense to you, okay? I particularly like hand trick. You can think about your first quadrant, but you got to know the first quadrant then. So if you're going to use that, you got to know the correct order of those numbers. Sine is defined in quadrants 1 and 4. This is a negative, which means it's coming in from quadrant 4. If I want a sine of 1/2, I would have one sine finger. My angle would have been pi over 6, negative to put me into quadrant 4. Second one, cosine of square root of 2 over 2. My reference angle would be pi over 4, positive. Everything is in quadrant 1. Tangent, you have to think of the unsimplified. Whichever method you look at, unsimplified, that'd be square root of 1 over square root of 3, or 1 over square root of 3. That would have looked like this. That's a pi over 6 reference angle. Pi over 6 on there. Positive puts us into quadrant 1. It is just pi over 6. Questions on any of the basics so far? Whether it's positive or negative. So if the problem starts out negative, you pick the negative option of the two quadrants that it's defined in. We have not talked on an axis. So to talk about being on an axis, we have to go back to the conversation we had when we were doing our unit circle. Every time we had an angle that fell on an axis, I asked you to think about the ordered pair that would put you to that point. For example, 1, 0 puts us on that axis, right? So when you're doing this, you want to think about those ordered pairs. This is 0, 1, negative 1, 0, 0, negative 1. And then what those angles are, where things are defined, that's like the foundation of it. Sine is defined in quadrants 1 and 4. It hits 3 different axes. It hits up here at pi over 2, at 0, and at negative pi over 2. Well, at pi over 2, sine has a value of 1, which means pi over 2 would have been the answer if the question was, what is the inverse sine of 1? Where does sine have a value of 1? The angle pi over 2. At 0, sine has a value of 0. So to get that as an answer, the question would have been, what is the inverse sine of 0? To get an answer of pi over 2, sine has a value of negative 1 down there. So negative pi over 2 is the answer to the question, what is the inverse sine of negative 1? Tangent is the same two quadrants, but it is not defined up here at pi over 2. It is not defined at negative pi over 2. That's where the asymptotes were. It doesn't get there. So the only axis it actually hits is here at 0. Tangent is sine over cosine, which would be 0 over 1. So that would be the answer to the question, what is the inverse tangent of 0? Is 0. Cosine is defined in quadrants 1 and 2. Hits 3 axes, 0, pi over 2, and pi. If we think about what the cosine value is at each of those, it tells us what the question was. The cosine value here is 1. So 0 is the answer to what is the inverse cosine of 1. Up at pi over 2, cosine has a value of 0. So pi over 2 is the answer to the question, what is the inverse cosine of 0? Over here at pi, cosine has a value of -1, so pi is the answer to the question, what is the inverse cosine of -1? I have already talked about this twice today, but a third time. The one that always bothers people, notice I did not ask you the question, what is the inverse tangent of 1? Okay, what is the inverse tangent of 1? Pi over 4. It does not fall on an axis, right? Pi over 4, square root of 2 over 2. That is, again, everyone wants tangent of 1 to fall on an axis. Inverse tangent of 1 is pi over 4, not on an axis. Probably the most missed question on your quiz next week. At pi over 2. I want to say Wednesday.
Oh, that's close. But 2 days ahead of time. I guess today is Thursday. So.
We'll get there. Okay, our last little part here is your introduction to where you guys will pick up on Monday. Okay, so I lied. It might be on Thursday, now that I say that. It's not. Okay, but you guys will have these two-fold questions. They are basically just 2 questions layered on top of each other. You only do one at a time. So when you are given these two-fold questions, notice it doesn't matter the order. They can go both directions. The inverse can be on the outside, or the inverse can be on the inside. You'll always have one of each. You can't have one of the same on both of those. But you just ignore the outside problem for a second, and you just do the inside question. We have to slow down because doing the old gateway questions, the old unit circle questions, they are so similar. So you have to remind yourself how you got through those questions. I will tell you, remember we started all of these questions by drawing the angle for ourselves. So if it asks me to do the tangent of 3 pi over 4, the first thing we would have all done is drawn an angle of 3 pi over 4. Whether that became in our head eventually or on our paper. And then we think through the all students take calc to decide if our answer was positive or negative. 3 pi over 4 puts us into quadrant 2. Tangent is negative in quadrant 2, so my answer is negative. We thought about our reference angle. That reference angle either took us to our hand trick reference angle, it took us to the special right triangle if we were a special right triangles person, it took us to our pi over 4 if we're a memorized quadrant 1 person. I'm a hand trick person, so there's pi over 4. It is square root of 2 over 2, which simplifies to 1. Negative because we're in quadrant 2. Then we transition to the outside problem and we shift gears because one of them is going to be normal gateway questions, one of them is going to be inverse, which we just learned today. Inverse cosine is defined in quadrants 1 and 2, correct? Positive in quadrant 1, negative in quadrant 2. If it is a 1, a 0, or a -1, it's going to fall on an axis. So think about your cosine values at each of those points. Cosine is the first number in each ordered pair. Cosine would be 1 here, 0 here, and -1 here. So our angle that gives us a cosine value of -1 is pi. We'll get there. We'll get there. Okay. Same thing on the next one. Again, we hold off on the outer function. It just hangs out while we do the inside problem. Inside problem is an inverse cosine. So again, inverse cosine is defined in quadrants 1 and 2. This is a positive number, so our answer is going to come from quadrant 1. Again, I'm a hand trick person. Cosine is my top fingers. If I want a cosine of 1/2, my reference angle would be a pi over 3. Positive pi over 3 in quadrant 1 is just pi over 3, right? And then I transition to my outside problem, sine of pi over 3. So that's a gateway question that I would have drawn my angle, thought about all students take calc. It's in quadrant 1. Everything's positive in quadrant 1, so my answer is positive. go to my method, whatever my method is, hand trick, memorized. Pi over 3 is our reference angle. Sine is square root of my bottom fingers over 2, so square root of 3 over 2. Questions? Yesterday we drew the graphs of these pictures. I want you to picture drawing me an inverse sine or an inverse cosine. What was the domain, farthest left to farthest right, that we drew those graphs? You marked it on your x-axis. Negative 1 to 1, right? That's the domain. Domain means what numbers we can plug into the function, right? So as I flip to this next page, it's a conversation about the domain restrictions of these functions. We talked about the domain restriction yesterday being negative 1 to 1 of inverse sine and inverse cosine. That's the farthest left and the farthest right. We graphed them. So when I go to plug in a number, it must fall in that domain from negative 1 to 1. Does 4 fall in that domain? No. You cannot find the inverse sine or the inverse cosine of something outside of that domain. So it is possible that these problems have answers that are described as does not exist. That's not a problem we can do. Monday, we'll spend a lot more time talking about why that is not a problem we can do. For right now, just understand it's not in your domain. Negative 1 to 1, can't do it. Tangent, however, had arrows that pointed both directions, right? So its domain was unrestricted. It goes from negative infinity to infinity. We can plug in all numbers to an inverse tangent function. Now, we don't have the tools right now to figure out what the inverse tangent of 4 is, but on Monday you will. I know it says tomorrow, not tomorrow, Monday. You guys will learn how to do that, okay? Any questions for me?